Okay, so with this video, we're going to just work a little bit on empirical formulas to help you get ready for the test. So we have this problem here as an example. Magnesium sulfate has a formula of MgSO4.7H2O. That means um, I have seven waters that are attached to this compound. Okay, because this compound is ionic, it has a metal in it, so that makes it ionic. Um, because of those charges, it can allow water to get in between those molecules. Um, and that's what a hydrate is. It's something that has water added to it, just like you're hydrated when you drink water. So anhydrous would mean that there's not any water in it. So the first thing we have to do is calculate the molar mass of the hydrated Epsom salt. So this is the chemical formula of Epsom salts, that you use when you have muscle soreness and that kind of thing. So we're going to take, to find the molar mass, we're just going to add up the atomic masses of each of these elements that are present here. And you would do that by looking these up on the periodic table. So let's add a periodic table here. And you will have one of these in the test question when you take your test. That's not what I wanted. Okay, so if I look here, magnesium is 24.3. So I'm going to have, and you'll need to make sure you show all your work. So 24.3. There should be a decimal there. I'm not getting it. There we go. Then I have sulfur, which if you look that up on the periodic table is 32. And then we have 4 oxygens, which if you look those up, those are 15.99, which actually we just round to 16. Okay, and then for the waters, this 7 here acts like a coefficient does in math. So that's 7 times 2. That means we have 14 hydrogens. And then I have, and that 7 goes with the oxygen as well. So I have 7 more. Let's see, let's hide this. Oxygens. So I'm going to add all of that up together. 24 plus 32 plus 64 plus 14 and some change plus 7 times 16. So on my calculator, if I add all of that up together, so that's really 7, 8, 9, 10, 11 oxygens. So 11 times 16 plus 24.3 plus 32 plus 14 times 1.008 is 246.41 grams per mole. That is the molar mass, so that is A. Okay. B, calculate the molar mass of the anhydrous salt. Okay. Well, the anhydrous salt, that means without water. So I would simply subtract out the water, or I would just add these three together, and that would give me my anhydrous salt. So 24.3 plus 32 plus 64 is 120.3 grams per mole. And this is for the anhydrous. Okay. Then it says calculate the percent by mass of the anhydrous salt. So to do C, so this is B here. So to do C, what we're going to do is we're just going to take the, since it's a percentage, we're going to take the 120.3 grams of the anhydrous salt and we're going to divide it by the total number of grams of the compound. So that's going to be 120.3 divided by 246.41 times 100. So 120.3 plus 246.41. Oops, not supposed to add those two together. Sorry, you're supposed to divide those two. Times 100 to make it a percentage gives me 48.82%. Okay, that's C. On D, it says explain what type of compound an anhydrous salt is. Is it ionic? Is it covalent? Or is it an acid? Well, it is going to be ionic because I have a metal, and I do not have a hydrogen in front. That would make it an acid. If I had all nonmetals, that would make it covalent. So as far as metals, nonmetals, and so on, please remember that everything, this staircase right here, that's in pink, those are your metalloids. Okay, so everything to the left of those, so that means from here on over, those are all metals. Everything up here, those are all non-metals. And then you have your metalloids in the middle. Remember, we did this at the very beginning of the school year when you had to identify the different parts of the periodic table. Okay. All right. Okay, so let's look at another example with empirical formulas. Not that one yet. Let's do this one. So what is the empirical formula of a compound with the following composition? So the first thing we need to do is we need to make sure that we understand that we are basing this off of 100 grams. So we need to remember that we're basing this are we assuming we have 100 grams? So we would have 10.4 grams of carbon, 27.8 grams of sulfur, and 61.7 grams of chlorine. So the next step is that we change all of these grams into moles using our little railroad tracks here. Okay, so grams of carbon in 1 mole of carbon is 12. We get that off the periodic table. Grams of sulfur in 1 mole of sulfur would be 32. And grams of chlorine in 1 mole of chlorine would be 35.5 actually. Okay, so we're going to just divide these out now. So 61.3 divided by 35.5 is 1.72, or actually it's 73. 27.8 divided by 32 is 0.86. And this is moles. And 10.4 divided by 12 is again 0.87. So what I'm going to do is I'm going to divide all of these by the smallest number, which is 0.86. So that's going to give me 1. This is going to give me 1. And 1.73 divided by 0.86 is 2. So what that means is that I have 1 carbon in my formula, I have 1 sulfur in my formula, and I have 2 chlorines in my formula. So this is my empirical formula right there. And that's how you do all your empirical formula problems. All right, next one. So one compound of platinum and chlorine is known to consist of 42% chlorine. What is the empirical formula? All right, so you only have two things in it. So if it's 42% chlorine, that means it's 42.1 grams of chlorine. And then if we subtract that, 100 minus 42.1 means it's 57.9 grams of platinum. So what I'm going to do is turn grams into moles. So that's going to be 35.5 grams in 1 mole of chlorine. And then the atomic mass of platinum, let's look up what that is. Platinum is PT, that's 195. Oops. Let's see if our decimal is right. 195, yeah. And 1 mole of platinum. So 42.1 divided by 35.5 is 1.2. And then 57.9 divided by 195 is 0.3. So I'm going to divide by the smallest number. Remember, we're talking about moles here. So that means I have 1 platinum, and that's going to be 4. 1.2 divided by 0.3 is 4 chlorines. So my empirical formula is PtCl4. Empirical formula for NO2, that's the empirical formula of a compound, is NO2. Its molecular mass is 92 grams per mole. What's the molecular formula? Okay, so on this one, what you have to remember is that empirical formula and molecular formula are just ratios of each other. The molecular formula is just a multiple of the empirical formula. So what we need to do is we need to find the mass of the empirical formula. So that's going to be 14 plus 2 times 16. 2 times 16 is 32, so 14 plus 32 is 46 grams per mole. And then we're just going to make a ratio of that to the molecular formula. So 92 divided by 46. 92 divided by 46. Again, I'm just dividing by the smaller number. It means 2. Okay, so my molecular formula is twice the ratio of the empirical formula. So it's 2 times whatever the empirical formula is. So I'm just going to multiply this by 2. So that would give me N2O4. And that's all I do. I just multiply that by 2. That gives me N2O4 as my molecular formula. Okay. All right. There was one that I want to come back to because it didn't have anything to do with molecular formulas. This is just a unit multiplier or conversion problem. It says how many molecules are in 2.5 grams of copper sulfate pentahydrate. So we're going to start with what we were given, and that's the 2.5 grams of copper sulfate pentahydrate. And we're going to turn those grams into moles. So to find the number of grams in 1 mole of anything, I would just add up all of the elements that are present there. So I have 10 waters, so that's 10 times 1.008, plus I have 5 waters, or 5 hydrogens in the water, so plus 5 times 16. So that means this water part is 90. Okay, then I look on my periodic table and I see that copper is 63.5. So 63.5 plus, the sulfur, which is 32, plus the 4 oxygens, which are 16. And then so this part is 159.5. And I'm going to add that to the 90 that's there. Gives me 249.5. Grams. Grams cancel out. But it asked me to find the number of molecules. So what I've got to do now is I got to convert moles into molecules. And that's Avogadro's number. So if I have 1 mole of something, that is always equal to Avogadro's number of those things. Okay, so what I'm going to do is I'm going to multiply across the top. So that'd be 2.5 times Avogadro's number, 6.022 times 10 to the 23rd. And then I'm going to divide by what's on the bottom, which would be 249.5, which gives me 6.03 times 10 to the 21st power molecules. Okay? All right. I think we've covered everything else. So good luck. If you have any questions, come to the Google Meet tomorrow.